So to do this, we're still just going to kind of do it the same way we did the equations. We're going to do one with the positive and then one with the negative. So we'll have two inequalities. So the first one is 2x minus 1 is greater than 7. Then the other one we have 2x minus 1 is less than negative 7. So when you do the negative one, you have to flip the inequality sign.
So you flip it and change it to a negative?
Yeah.
We're going to graph both of them.
We are. But we'll do them on the same number line. So then we just solve these like we would. So we're going to add 1 to both sides, giving us 2x is greater than 8, divided by 2. So we get x is greater than 4. And then for the other side, we're going to add 1. So 2x is less than negative 6, divided by 2. So x is less than negative 3. So then to graph these, we're going to put them both on the same number line. So we have a negative 3 and a 4. So for 4, right, that's going to be an open circle, and we're going to go to the right. And then at 3, it's also an open circle, but it's to the left. So you still just follow the arrows. So if both of those signs were flipped, you would just shade in between them like we did for the compound inequalities. Yes?
So whenever we're dividing, if that 2 was a negative, would we flip?
Yes.
But since it's not, we don't.
Right. Yeah, so only when you're dividing by something that's negative is when you flip it. Or if it was like a fraction and you multiply by something negative, then you would flip it as well. But yeah, multiplying or dividing by a negative flips it. All right, so questions so far? Do we have any? How are we feeling? Okay.
We never did this in public school.
Really?
I don't remember ever doing this.
Inequalities are just the absolute value ones?
Inequality.
Oh, that's interesting.
Like, we did like less than and stuff like that, but we didn't do it.
Like solving them?
Yeah, we didn't do it that much.
Gotcha.
Those are the ones I typically don't understand.
It's not that bad.
That's what you always say.
And how often has it been that miserable? You guys are just very dramatic.
What? You're not wrong.
At least Kirsten admits it. All right, so what are we going to do first? Divide by 3. See, that's not that bad. Now Ethan's being dramatic. You're not normally the dramatic one.
Well, since he only has a few more days left.
He's got to get it out. All right. All right, so then we're going to do, just like we did before, we're going to write two inequalities. So we're going to have 5 minus 3x is less than 4. And then 5 minus 3x is greater than negative 4. So don't forget to flip it. I should probably. All right, and then we solve. So we're going to subtract 5 from both sides. So negative 3x is less than negative 1. divide by negative 3. We're dividing by negative 3. What does that mean? Flip the sign. So it's x is greater than 1/3. And then on this side, we're going to do the same thing. We're going to subtract 5 from both sides, which gives us negative 3x is greater than negative 9. Divide by negative 3. And x is less than 3. So for this one, when we graph it, so we have 1/3 and 3. So we have an open circle at 1/3, and we're going to shade to the right. Then I'm going to stop at 3 because we have an open circle at 3, but that one would go to the left. So you just shade in between the two when that would happen. You don't like go all the way over and then over again, because then your whole line would be shaded. You just shade in between the two when that happens. All right, and then just two more kind of little things. So when we've got a negative on that other side of our inequality, so let's say we have 4x minus 3 is less than negative 6. If it is less than a negative, no solution. All right, so you have to have the less than and the negative for the no solution. All right, it has to be a less than. And then if you have it greater than, it could also be less than or equal to. You can have the or equal to's there as well. But if it's greater than a negative, anybody have a guess? All right, so all real numbers. So if it's greater than a negative, it's all real numbers. And if it is less than a negative, it's no solution.
But you don't have to solve it, you just, that's just.
Yes. Now, just like on the equations, if we had stuff kind of like on the outside, so if I had like, say, a -2 multiplied out here, I would want to divide that over, which would make it positive, and then I could solve it. So you always want to move your other stuff over first and like isolate the absolute value before you determine this. But once you get it where it's just an absolute value and a number, if it's less than a negative, it's no solution. If it's greater than a negative, it's all real numbers.
Is greater than also greater than or equal to?
Yes. Yeah. The or equal to's apply for both of these. All right. That's it for today. I mean, we got homework to do, but you still have 10 minutes. All right. So odd or evens? Odd or even?
Yeah, which one is easier?
They're really both the same.
Yeah, they look exactly the same.
I think I have evens on LMS, and I don't want to change it, so that's what we're going to go with. So page 82, 2 through 20, even.